Hello, teacher. Due to the assignment you gave us, I'm going to do my part of the presentation. To save up time, in 10 minutes, I'm going to be talking about vehicle to everything's network infrastructure and then proceed to the radio access protocol aspects. First, the architecture is divided into two categories, connection via side link and connection via network. For the network-based communication, it uses the LTE-UU interface between the vehicle and the ENBs. The user equipments send unicast messages via the ENB to an application server, which in turn rebroadcasts them via evolved multimedia broadcast multicast services. For all the user equipments in the relevant geographical area. LTE also use unicast and broadcast barriers for data transmission. Broadcast is applicable if the mobile operator has deployed EMBMs. LTE can complement the short-range communication path for V2X provided by other technologies. For the connection via side link, it also operates in two ways. Either the resources are allocated by the network or the devices select the resource autonomously. For the first one, it requires additional signal that results in an increasing of transmission latency, which can risk the safety of the passengers on the vehicle. And here comes the second mode that is way better when talking about optimization of resource allocation due to low latency. However, there is always the risk of possible collision and interferences. As you can see, to make it simple, here is an illustration that explains the connection that each device have with its environment. Here we can see for the vehicle-to-vehicle communication, the interface used is PC5. For the vehicle-to-network, it's the UU interface. We can also see that the vehicle-to-everything app will connect with the vehicle-to-everything servers via a V5 interface that I used to mention there. Because a V2X application servers, also V2X application servers communicate with each other via the interface out of scope of 3GPP specifications. We can't be talking about the vehicle to everything architecture without bringing up the vehicle to everything control function. It's a logical function that is used for network communication. More specifically, it is used to provide user equipment with network specific parameters that allow the user equipment to use vehicle to everything service in the PLMN. It is also used to configure the UE with the parameters when it's out of network coverage. Moving on to the network slicing. The V2N and communication via the network represents suitable applications for the network slicing. For instance, autonomous driving or safety emergency services will require a URLLC network slice. Meanwhile, some infotainment services or personal mobility services would require either a best effort slice or an NEMBB. A vehicle can access different slices at the same time, with passengers watching a high-definition movie, while a background application detects a road hazard and triggers an emergency message for the cars behind or nearby to slow down or stop to prevent an accident. The critical V2X can operate outside of network coverage using direct communication without requiring provisioning and universal subscriber identity model, USIM. Now moving on to the side link and radio access protocols. To dive in deepness of the architecture, let's do a reminder of what do we mean by side link communications. As I said before, it's a mode where user equipment communicate with each other using the PC5 interface. The user equipment performs and uses side link communication in subframes that are sent and received through SBCCH over the duration of side link control period. How user equipment performs side link communication? During the side link, the UE performs transmission and reception over the LTE, UE, and PC5 during the side link control period. Side link control period is the time reserved for the allocation of resources for SCI, side link control information, gain the user equipment since the SCI. The user equipment performs transmission and reception over the LTE, UU, and PC5 using a hierarchy from the highest priority to the lowest, starting off with UU transmission reception, PC5 side link communication transmission reception, and finally PC5 side link discovery, announcement, and monitoring. The UE radio protocol structures consists of two important protocols, the user plane protocol and the control plane protocol. The user plane protocol, also called the data plane, carries the network user traffic. A plane in a networking context is one of three integral components of a telecommunications architecture. These three elements are the data plane, the control plane, and the management plane. The user plane protocol stack between the E-node B and user equipment consists of the following sublayers: PDCP, Packet Data Convergence Protocol, RLC, Radio Link Control, and Medium Access Control, MAC. The control plane includes the Radio Resource Control Layer, RRC, which is responsible for configuring the lower layers. The management plane of a networking device is the element within a system that configures, monitors, and provides management, monitoring, and configuration services to all layers of the network stack and other parts of the system. The control plane. The control plane is the part of a network that carries signal traffic and is responsible for routing. Control packets originate from or are designated for a router. Functions of the control plane include system configuration and management. The control plane, the data plane, and the management plane are the three basic components of a telecommunication architecture. The control plane and management plane serve the data plane, which bears the traffic that the network exists to carry. The management plane, which carries administrative traffic, is considered a subset of the control plane. In conventional networking, all three planes are implemented in the firmware of routers and switches. Software-defined networking, SDN, decouples the data and control planes, removes the control plane from network hardware and implements it in software instead, which enables programmatic access and as a result makes network administration much more flexible. Moving the control plane to software allow dynamic access and administration, and network administrator can shape traffic from a centralized control console without having to touch individual switches. The administrator can change any network switches rule when necessary, prioritizing, deprioritizing, or even blocking specific types of packets with a very granular level of control. Thank you, teacher, for your attention. I hope you liked the presentation. Thank you.